just super easy. Oh, you snuck in. I'll mark you here. Don't worry. Sorry. Wow, no questions? Limits are good? Yeah, I guess it is sort of like a return to Calc 1. How do we do limits? What do you think, Michael? I sure can. Did I assign 49? There it is. Nth root of n. Yum. Okay, what are we doing here? Just a minute. I got to make sure. Determine whether the sequence converges or diverges. Okay, very good. So nth root of n, where is it? 49. Oh, why do I need to? Wait, it is the nth root of n, isn't it? Oh, no, it isn't. It's the natural log. Sorry, 49?
Yeah.
Okay, I got excited when I saw this. So it's this one, though. Okay, natural log of 2n plus 1 minus natural log of n squared. Okay, so what's going to happen here is when you do a limit, so let's go ahead and do the limit. As n approaches infinity of this thing, you get infinity minus infinity. What is infinity minus infinity? Well, it turns out infinity minus infinity could be any number. Because imagine going infinity is that direction, isn't it? Go an infinite distance that way, turn around, and then come back an infinite distance. Where do you end up? Your guess is as good as mine. So in order to figure out whether we end up somewhere here or if we end up way over there, we're going to actually have to do a little bit of math, but it's not hard math. So you have to remember that this stuff can be rearranged, combined into a single logarithm. So you have the limit as n approaches infinity of this logarithm, 2n squared plus 1 over n squared plus 1. And that is something that I can do. So and then we're going to use the rules of limits that say that you can take this limit and move it, since this is a continuous function, move this inside the function. So this is going to equal the natural log of the limit as n approaches infinity of this. And then this is something that is super easy. We could do it, with the correct way, or we could just look at it and say the answer is 2, right? The answer is 2. Take the leading coefficient because these have the same degree. So the final answer is going to be the natural log of 2. So it does have a limit. This does converges to natural log of 2. Anything else before we go on? So I have a couple of quiz questions that are similar to the homework. If you didn't have any trouble with the homework, you shouldn't have any trouble with this. Let's give this a try and see how you do. Oh, I'm going to go to the back first. Sorry, I know I always favor the front. So let's start in the back. Here you are. Enjoy. 1, 2, 3. I think that's only 3. So let me give you another one. There's 2. And there's one more. There you go. 1, 2. Here, these are for them. This is for you. 1, 2, 3, I think. Here you go. You shove one over to Ben. There you go. 1, 2. There's 3, and Carson is last, but you're not going to take too long, I'm sure. All right. Did everyone get one? Who wants one? All right. I'll put it up on the screen for the absent people once I find it here. There it is. Where's my thing? Well, you're probably done. Took me longer than you probably, but so if you are done, feel free to send your paper over. Okay, maybe you took a little longer than me, so I'll give you another couple minutes. Sorry, I jumped the gun there. All right, so you weren't at that much of a disadvantage getting it last. Good job. All set, Ben? You're all caffeined up. So, wait, is this a little sewing kit?
No, this is eraser in it.
Oh, okay, I get it. Okay, I actually have a sewing kit that is in a little container that looks like this. So, just curious. You're all set? Yeah, I'm not rushing you, am I? All right. Yeah, look good. You're all set. Very nice. Oh, beautiful. Nice. Interesting. Let's see. Is this you? All set? Okay. I don't want to rush you, but I figure you're probably in good shape. Sure. I always get a lot of steps when I wander around. Good job. Thanks. You're all set, Maggie? Okay. Nice. Thank you, Hayden. This one's for me. All right. Let's see. Is that going to help? Okay. All right. All right. You're all set? Oh, you are too. Nice. Good job. All right, you're happy now?
Yep.
Okay, that's all I can hope for is just a little bit of joy and happiness. What do you think? Look good? Looks great. Oh, I love it. I love it. Very nice. Just waiting on the last. Oh, you've got answers. You just don't like your answers?
I don't like one of the answers.
Oh, which one don't you like? That one?
I'm pretty sure it's
I like it.
okay. I did
Wait,
write that.
is this the correct? Is this what? Not that. This. Is this your answer or is this your answer?
This is already
This one?
Yeah.
Okay. I'm happy. All right. Which one? Oh, you don't like that one either? What's up with that?
I don't have one.
Oh, I see. You can take a guess.
I could.
Yeah. Pick a number, any number. That's a number.
Yeah, it is. But
All right, I'll come right back. I'm going to get the last one over here and then I'll come back. Who's got my last? Oh, you've got it. Anyone else? Ah, there we go. It's a fight to see who gets it done first. All right, yeah, put a box around it and then take a guess. You can do it. You can do it. I'll come right back. Did you get it? There? Finally? All right. Wait, what did you do to do that?
I just
Oh.
typed it down.
All right. Did you get it? Take a guess. You can do it. Okay, diverge. Very nice. Okay, I think I got them all. Do I have all of them? Any holdouts? No, good. So let's see how this works. Unfreeze. Beautiful. So the first one was super easy. You're just plugging in numbers, plug 1 into this. You get -1 times 1 over 2, which is -1/2. And then the pattern looks pretty easy. 2/4, -3/8, 4/16, -5/32. You probably could continue the pattern after that, but there it is. Formula. So here, so hopefully it wasn't terribly difficult. You're just looking for some formula that when you plug in 1, you get 11. When you plug 2 into it, you get 12. When you plug 3 into it, you get 13. N plus 10 works. So, or 10 plus N, I think I have 10 plus N. So something like that. I saw a couple of people with 11 plus N. I might squint when I look at yours because that would be the correct formula if you began with N equals 0 instead of N equals 1. So anyway, moving on. The limits. This wasn't supposed to be tricky, but apparently it was. So here, the limit of this, the -1 doesn't really play into this because when you plug in a big number, like N equals 1,000,000, you get -1 to the million power over 1,000,000 squared, which is basically 0. So this thing goes to 0. I didn't show any work, but what's there to show? And then this one was just a nice, easy polynomial. You're just dealing with the leading coefficients. So that's that trick there with the leading coefficients. So those are the correct answers. Let's move on. We're doing series today. I always have trouble with this. The reason is whenever I'm talking about series, I have to say stuff like this. A series does such and such. And yeah, here, you can't see it, but she's waiting for me now. Go away. Yeah, so Siri opens up. Oh, now she's up. There she is again. No, I don't need you. Okay. So yeah, it's going to be I've got my sound turned off, but sometimes she's like, "How can I help you?" Maybe I'll turn up the sound just for fun. So that we can. Oh, it is up. I don't know why she didn't talk to me earlier. Maybe she doesn't love me anymore. Okay, so series. Series are sums. That's it. Series equals a sum. But more importantly, it is an infinite sum, a sum of an infinite terms. So you're adding together an infinite number of terms. That's all it is. Series are sums. You're adding together a bunch of stuff. What? So, well, this is pi, sure. Yeah, so pi, actually any irrational number, any rational number for that matter, can be written as a sum of the different digits. Okay, so this is like a super basic 3.141592665 and so on. So not very exciting, but it's kind of, that's the sort of thing that we're doing. So what we're interested in is things like this, that pi is also equal to the sum of 4 times -1 to the n over 2n, let me see if I get this right, -1. And this is n goes from 1 to infinity. Okay, so what's this? This is, 0. We'll go from 0 to infinity and put a plus there. How's that? Okay, that'll be better. So this is 4 minus 4 over 3 plus 4 over 5 minus 4 over 7. If you do this forever and ever, this is another way of writing pi. It's going to take a lot longer to get to pi this way than it is this way. So but what we're interested in calculus is things like this one down here, where we're adding together a bunch of numbers, and you put some dots here, and it turns out that if you do this, you also get pi. In fact, there are a bunch of different series representations of pi, and this is just one of many. And anytime, like the Chodnovsky brothers, who have computed 1 billion digits of pi, they use much more complicated summations than this. So anyway, that's where we're heading with this, is understanding that sort of thing. And we will get there. We will get to the point where that actually formula, that makes sense, will prove that that's the case, but not yet. For now, we just want to understand what it means to be a summation or a series. Okay, so infinite series or just series is something like this. So we're going to write it like that. And that sort of symbols, that just means this. You're adding together the terms of a sequence. So there are formulas. There are formulas that will allow you to add up the terms of a summation. And so let me remind you, or maybe show you for the first time, how you add up the terms of a sequence. So let me here, we'll start with an arithmetic sequence. Or arithmetic series. Let's say you want to add together these numbers. I'll take a nice easy arithmetic sequence here. 4, 5, 6, 7. Let's see, where should we stop? 8, 9. Should we just stop there for fun? Yeah, we'll stop there. So do you know what the formula is for adding together those first 10 numbers? Anyone know offhand? You do? Yeah, that's what it is. It's the sum. No, but I want to know what the number is. Do you know the number? Yeah, when you add them all up. Can you add them all up? You can add them all up? 55, you're right. Did you add them all up or do you have a formula? Oh, very good. Yes, half the numbers times 11. That's exactly the formula. Very good. So if you wanted to add up these numbers, plus 3, plus plus 100, we could do the same thing, couldn't we? Half the numbers times, wait, not times 11 though. Okay, so that would be 101. So half of the terms, which is 50, 50 times 101, which is going to equal 50, 50. Now, the formula, though, is a little bit more complicated than that. That formula works. Don't worry, I'll write down the formula if you're like, what does he mean by half the terms? I'll show you, don't worry. But if you have a different arithmetic sequence, for example, this one, 3 plus 8 plus 13 plus 18 plus 23. Let's go, I better write it out. 28. No, I don't need to write it out. I'll just go up to 98. So what about this one? Well, the formula for an arithmetic sequence is this. You take the number of terms divided by 2 times the first plus the last. So there it is. That's actually pretty straightforward. So how many terms do you have? There are 20 terms here. I know you can't see them all because of the dots, but you can figure it out. You have 2 terms between 0 and 10, 2 terms between 10 and 20, 2, and so on. That's a total of 20 terms. 20 terms. So this will be 20 divided by 2 times the first plus the last. Notice that that works up here as well. If we do the first plus the last times the number of terms divided by 2, there it is. You get 50 times 101, which is 50, 50. And same thing up here. If you take the number of terms 11 divided by 2 times the first, 10 terms. 10 divided by 2 times the first plus the last. You might wonder what happens if you have an odd number of terms. It's going to be okay. If you have an odd number of terms, it'll all come out in the wash because that'll just be 21 over 2 times 3 plus 103. It'll always be the case that if there's an odd number of terms, then these two numbers will be the same parity, which means that you'll have an even number when you add them together. So 21 times this divided by 2 is the answer there. So that's the idea for a series and a way to add up a bunch of numbers that are in an arithmetic sequence, which is called an arithmetic series. What about a geometric series? What if we want to add these together? 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. That's a little bit harder, but it might be something that you've done before. Let me write down the formula for this. What you do is you take the first term times, let's see if I got this right. Sorry. Oh, here, actually, I got to derive this formula because I can't remember the, can't remember the details exactly. So let's rederive. This one's easy. So what I have here is r to the 0 plus r to the first plus r to the second plus r to the third plus r to the fourth plus r to the fifth. And that is r is equal to 1/2. So r is going to be the common ratio. So what am I multiplying by each time to get to the next term? So that's what we mean by r. And so to figure this out, the way I remember it, actually now I remember my formula, but for whatever reason I didn't just a minute ago, is I multiply by 1 minus r. And what I get is I get 1 minus r to the n plus 1. And so if you divide both sides by 1 minus r, there it is. Okay, so the correct formula for a geometric series is you take the first times the following fraction, 1 minus the common ratio to the number of terms over 1 minus the common ratio. So n is the number of terms. And I know you're saying, wait a minute, there's a 5 there and a 6 there. But if you count 1, 2, 3, 4, 5, 6, there are 6 terms that I'm adding together. So you take the first term that, let me demonstrate. Let's say that I want to add up these. 3 plus 6 plus 12 plus 24 plus 48, one more, plus 96. What is that sum going to be? Well, I'm going to take the first term, 3, times the following fraction. I need to know the common ratio, so I'll bet you can tell me that. So bin in the back, bin H, what is the common ratio here? What am I multiplying by to get the next term in this sequence? Yeah, it's just 2, right? 2, then you multiply by 2 again. Okay, so this is going to be 1 minus 2 to, let's see, what power am I going to do? I've got 1, 2, 3, 4, 5, 6. So this is 6 terms. So I'm going to raise this to the 6th power over 1 minus 2. And that's going to give me my my final answer, which I don't have enough room over here, but I can do it in my head. 2 to the 6th is 64. 1 minus 64 is negative 63 over negative 1. So this will be 63 times 3, 189, if you add up these numbers. And you can do it on your calculator if you want to check my work, but you will get 189. Isn't that cool? Nice little formula for computing the sum of a geometric series. Now, of course, we're not so interested in this because this is a finite summation. We're stopping and we're like, oh, we're all done. We want to go forever. We want to know what happens when we keep adding terms forever. And that's the goal here. So series, can we find the sum for this series? So I'm adding up these numbers. Notice it's 1 plus 2 plus 3. And I'm going to go forever. That's what this means. So let me just write this down. This is the sum where n goes from 1 to infinity of n. So I'm adding together the integers. Can I find a finite sum, or does this diverge? What's your feeling on this one? Do you think it diverges, or does it converge to a number? We could actually do it on a calculator. 1 plus 2 plus 3 plus 4 plus 5. Keep going. Forever. Is that ever going to get to a single number? No, you just don't want to admit it. I see. I have to pick someone. But you say no, it's not. You're right. It's not going to, because you're adding bigger and bigger numbers. When I get over to 100, I'm adding 100, then 101, then 102. Then I'm adding 1,000,000, then 1,000,001, and then I'm adding 1,000,000,000. The numbers keep getting bigger as I add up. So this thing diverges. This one diverges. Diverge. Okay, what about this one? Let's say I add up these fractions. This one you might want to actually do, and I'm going to do it. I'm going to do it on a calculator. Here, oh, better yet, I'm going to do it in Python. Let's do it really quick here. Do I have time to do it? Sure, why not? Okay, just a sec. Okay. New. Okay, just give me a sec here. Just need to make a quick loop. Okay, here we go. So for I in range, I'll just go a big number. I picked like 10 billion. I'll show you in a minute. Here, I'll put it up on the screen. You can see. There we go. Oh, I forgot to start with something. Give me a sec. I know you guys are quicker than me with your Python, but here, I'll just crank this out here real quick. So this is going to be total is equal to 0. And then we'll start our little loop. And we'll put a colon there. And then we'll do total plus equals 1. No, I. 1 over 2 to the I power. Isn't that what I'm doing? Yeah, that's what I'm doing. Okay, and then we'll print it. Okay. Let's see if we can crash this thing. What's wrong? Yeah, exactly. That's what I want to do. Okay, so let's see it. It's allocating runtime. Come on, show it to me. Why isn't it printing yet? Oh, here. Oh, what? Why? Oh, the exponent. I'm sorry, I forgot. Python doesn't know how to use the caret there. That's better. Okay, that's better. Okay, so, 2? What? Why is it just giving me 2? Hold on a minute. Let's stop this. Okay, well, okay, I give up. I don't care. So I'll deal with it later. Yeah, I should have had that prepped ahead of time. But you get the picture. Is that if I were to do this, I would get 1/2, 1/2. I was hoping that it would spit out like 0.5 and then 0.75 because the next thing is 3/4. And then when I add in the 1/8, I actually end up with 7/8. So these are the numbers that I would get when I plug in. In fact, I have them here. I don't know why I didn't just show you this. So if I add up the first in terms, I start off with 0.5 and then 0.75, 0.875, 0.9. Notice what's happening. What is the limit? What do you think this is going to be if I keep going to infinity? Any guesses? You got it back there? 1? Sure, we'll go to 1, right? The limit is probably going to be 1, and it is 1. So that's what we're going to do. So what we'll do is we'll say, hey, that series converges to 1. So back here, this one diverges. This one converges to 1. Our job today is basically just to understand that and to deal with one relatively simple formula. So before we get to the relatively simple formula, I need to mention something about partial sums. So these things, these numbers, and the things that I was trying to get with Python, but I just should have done it ahead of time to make sure it worked. These things are called partial sums. This is the partial sum of the first 1 term, first 2 terms, 3 terms, 4 terms, 25 terms, and so on. And so here is sort of formally what we mean by partial sums. So if that's what partial sums are, we could actually write down a formula for the partial sums of this series. So yeah, I wouldn't necessarily write down all of this. You can always watch the video and then stop. But the main thing is that a partial sum is exactly what it sounds like. We're stopping, we're going partial, almost the way, not all the way, partially, not all the way there. So let's go back to this and let's see if we can come up with the partial sums. S sub 1 is 1/2. S sub 2 is 1/2 plus 1/4. S sub 3 is 1/2 plus 1/4 plus 1/8. I'm getting sick of writing this, so I'm just going to do this. S sub n is 1/2 plus 1/4 plus ... plus 1/2 to the n. Notice that the partial sum, you stop at whatever term you are at. So this is in general what it's going to look like. Notice that there's no dots after here, but we have a formula. We have a formula. This is a geometric series. The formula is you take the first term you multiply this by 1 minus the common ratio raised to the number of terms. So how many terms do we have here? This is 1 over 2 to the first, second, third. It looks like when you have 3, there's 3 terms. 4 is 4 times 3. This is going to be to the n, yeah, it's the number of terms, all over 1 minus the common ratio. So there's the formula. It looks scary, doesn't it? But it's going to be okay. We're going to be able to do this. So all of this is this 1/2, give me a minute here, times 1 minus 1/2 to the n over 1/2. And I hope you can see that those 1/2s are going to cancel, and you're going to be left with this 1 minus 1/2 to the n. So what I've done is I've taken the partial sums, and I've got a formula for the partial sums, and I'll bet you can guess what's going to happen is to figure out the limit of a series, you do the limit of the partial sums. So the this summation, n goes from 1 to infinity of 1 over 2 to the n, is going to be the limit as n approaches infinity of this thing over here, 1 minus 1/2 to the n power, which is just 1. So you can do this, can't you? You can do that limit. It's not that hard. If it bothers you, you could write this as 1 over 2 to the n, 1 over 2 to the n, which is the limit will be 0, because the bigger number you put in here, the smaller that fraction becomes. So eventually you get to 1. So that's what we want to be able to do today with some specific types of series. So let's see, I'm going to skip that one for a minute. We'll come back to it though, don't worry. And let us move on to this. Here we go. So geometric series. Geometric series just because they're pretty easy. That's the one that we just did, the one with the 1/2. You have a common ratio, and you have this first term. So just so you can see what I've got here, how it relates to the formula I had before, this is the first term. So the first is equal to A. That's not too bad. And then, of course, the R is the common ratio. Common ratio is R. So we'll have some examples, don't worry. So back here we go. There's a hint as to how you're going to do these. So the hint is that in each case, what ends up happening is you end up with something that looks like this. So let's, here I'll highlight, because this one is the important one. This is going to be our guide. Here we go, I'll highlight it, that one right there. And the only difference whenever we have a different geometric series is this 1/2 here will be whatever the first term is. So whatever your first term is, you'll put it here. And then these two will both be the common ratio. But here's the cool thing, is that when I do a limit as n approaches infinity of this, because there's the only n, this, as long as that 1/2, as long as that common ratio is smaller than 1, this will end up just, the limit will be 1. So it'll be 1 minus 0, which is 1. So that's the key to this, is that anytime you have a geometric series, if your common ratio is small enough, less than 1, then this thing will converge. And specifically, well, okay, so first of all, what happens if the ratio is bigger than 1? Anyone want to guess? What happens if the ratio is bigger than 1? Diverges, very good. So you could think of I'll show you an example of a common ratio bigger than 1. Let's start with 7. Give me a sec. So 7 plus, let's see, something bigger than 1 is 3. 7 plus 21 plus 63 plus 3 times 63 is 189. Okay, so things get pretty ugly pretty quickly. But you can see things are blowing up very quickly. This is going to diverge. So if r is bigger, this is an r equals 3, for example. So r bigger than 1, you diverge. Okay, so what about if r equals 1? Any guesses? Oh, yeah, okay, Hayden. Nope, not 0. So here, I'll give you an example. When r equals 1, what that means is you have something like this. 5 plus the common ratio is 1. So I'm just going to keep writing down 5s, and I keep writing down 5s forever. What's happening there? Oh, pick a rando, because you guys don't, I've trained you to just be silent unless, give me a sec here. Here we go. Christopher, you know what's going to happen here, don't you? It still diverges, yes. So this one also diverges. Okay, now if r is less than 1, so now this is where things get interesting. If r is less than 1, then we can use that formula. So the formula is the first times 1 over 1 minus the common ratio. You might say, wait, wasn't it the common ratio up on top? Yes, but because r is less than 1, I'll show you this again. This thing, because r is less than 1, the limit as n approaches infinity of this is going to be 0, so you just end up with 1 over 1 minus the common ratio. And so that's going to be the formula. So this one will converge to this. Whatever the first is times 1 over 1 minus the common ratio. Now this actually, I'm kind of, this isn't quite true, because when I say r can be less than 1, what if r equals -3? So -3 is less than 1. So let's make it a little bit more correct. What I should have done is I should have put absolute values around these, so that if the absolute value of r is bigger than 1, you diverge. If the absolute value of r is less than 1, you converge. And if it equals 1, you diverge. So here's the rule. This comes right from your book. You can find this. I don't know what page it is. I could look it up. It's in section 11.2. But here's the rule, and that is that this thing diverges when the, here it is. So if the magnitude or the absolute value of r is bigger than 1 or equal to 1, you diverge. If it's less than 1, you get this as your formula. I don't like, well, actually I like that formula, it's correct. What I don't like about it is just that depending on what your n is, so like if you start the series at 1, this is the right formula. If you start the series at 2, then it's not the right formula. So that's why I like my formula better, because mine works no matter what you start in it. If you say n goes from 5 to infinity, just take the first term, whatever the first thing is, whatever's first. I'll show you. But first, let's do a few examples. Here's one example here. So I want to find the sum of this. So you're going to have to, first of all, figure out the common ratio. So I guess I already know the first term. I need the common ratio. So in the book would call that first term A. I'm just going to call it 5, or first. I'll just call it first. So I need the common ratio. So what is that I'm multiplying by each time to get my successive terms? That's the key. I'll give you a sec. You can share with your neighbor if you need to. Then I'll pick someone. All right, Ryan, what do you think? What do I do to get from one term to the next?
The top is 5n, then times parentheses -1 to the n. And I'm not quite sure on the bottom.
Well, you got 3, 9, 27. So
3 times 2 then.
okay, so let's. I'm gonna just. We're gonna put these sort of together. That on the bottom you're multiplying by 3, because notice that you have 3, and then 3 times 3 is 9, and 9 times 3 is 27. I think you're just trying to make it more complicated than it needs to be, but I think you've got all the pieces. Whoops, there it goes. So on top, yeah, if you get the formula the way Ryan was doing, you would have the common ratio. But all I want to know is, what did I do? 5 times r is equal to negative 10 thirds. Negative 10 thirds times r is equal to 20 ninths. That's what I'm talking about, is what do I multiply by? And so you're certainly multiplying by 3 on the bottom. There's a 2 on top, and there's a negative, because they negate. So that's where this is going. So you don't need to have an actual formula. I mean, a formula is nice, but all you need to do is just say, okay, what did I multiply 5 by to get this? Well, I multiplied it by 2/3, and I negated it. So 2/3, negative 2/3, you're good. And then if I take 10/3, multiply by negative 2/3, I get positive, because this is negative, it becomes positive. 20, 2, and 9, which is 3. So 2, 3. 2, 3. Notice each time you're multiplying by 2/3, 2/3, 2/3. Now that I've got that, all I have to do is to find the sum. Is I just plug this in, first term. Maybe I'll write it the way the book does. Hold on a sec. I'll do it 2 different ways. So you have the first term over 1 minus the common ratio. Or the way the book does it is a over 1 minus the common ratio, with the caveat that a is the first term. So just be careful with that one, because yeah, weird things, depending on how the thing is written, yeah, if you start your sum somewhere other than n equals 1, you'll have a problem with the book's version. So let's go ahead and do this. This is 5 over 1 minus 2/3, which is going to be 15. So you see how that works? It's not that bad. Let's do another one. Oh, you do? Let's do it.
Don't you need to add the 2/3 because it's negative?
Oh, good point. Yeah, I blew it. I was so excited about my thing coming out to be a nice equal integer that I blew it. So it's negative, thank you, negative 2/3. Drat. I guess it's still pretty good, isn't it? Because that equals 3. So that's not terrible. But it's not, I got excited about my 15. So yeah, do 1 minus negative 2/3, which is 5/3, and then do the flipping, the multiplying. You should get 3. Thank you. Thank you. Keep me honest here. All right, let's do a couple more. See how you do with these two. So here I've got them written out. I guess I didn't, I don't have the actual numbers, but in each case, what you need to do is you need to figure out what is the first term and what is the common ratio. So what is the first term and what is the common ratio? And then we will put that all together to be the first term over 1 minus the common ratio. So take a minute, see if you can work it out. And both of these, by the way, are good examples of why it's kind of a little hard to, if you were using the book's formula, you'd have to do a little bit more, I don't know, I find it to be trickier. It's not terrible, it still works, but. Oh, what time is it? We're good. All right, well, let's walk through this first one to make sure that you understand what I mean by first term. So Carson, do you know what the first term is for this first, the one, the 6/5 thing, that thing? It is 1. How did you get 1? So first term means you take whatever number is down here. In this case, it's n equals 1, but don't count on it. It might be n equals 2 for some of the problems that you look at. Plug it in to here, and you get the first term is equal to 1. Very nice. Now, common ratio, this is a little tricky, but it's not terrible. Let's see if you got it. Let's see. Darren, do you know what the common ratio is with this one? It is -6/5. So here's what I would suggest you do is you could do actually one of a couple of things, but one way to do this is to think about what is going to be like when I increase in from 1 to 2, what happens to this? Another way is just to write down, and this is probably the safest way, but it is time consuming, is to write down the first two terms. So A1 is equal to 1, A2 is -6/5, and then just do the ratio. Divide this by this, and you'll get that. Finally, let's use this formula, but wait, we can't use that formula, can we? The reason being that the common ratio is bigger than 1. Well, the absolute value of it. The common ratio is too big. Because the common ratio is too big, this is going to diverge. And then we're all done. So you can only use this formula when the common ratio is between -1 and +1. Otherwise, this thing diverges. All right, any questions about that first one? Yeah, Hayden.
How do we calculate the point that or do we just not have a commonly calculated?
You don't calculate it because it diverges,
Right.
which means it's infinite.
Okay.
So notice that the way that this is stated, determine if it converges or diverges. If it converges, then you find the sum. If it diverges, there's no sum. Unless you're using there's some weird, you're going to probably find, there's some weird math that you can do if you assume that this converges. And yeah, some weird stuff happens. But yeah, let's not go there. Yeah, so yeah, if you assume it converges, then weird stuff happens. But we're not going to go there. We're just going to stick with the traditional mathematics that we're learning. Okay, so let's do the next one. What's the, first term? So Daniel, do you know what the first term is for this second one? 1/4, very nice. So you're just plugging in n equals 1, and you get 1/4, very good. Now we need a common ratio. Caleb, do you know what the common ratio is for this one? Did you say there's a 4 and a 3, you said? So 3/4, you said? And then we have to be careful because there is a negative up here. So here, I'll do this the safe way. I'll write down the first term, and then the second term is -3/16. So the common ratio will be the ratio of those terms. So here, I'll do this right here. -3/16 divided by 1/4, which is -3/4. And that's the common. So that's the safest way to do this. But probably most of the time, it's reasonably safe to just note that you've got an extra 3 up here and an extra 4 down here. This only works, by the way, with geometric series. Before we leave, hopefully we'll have a chance for one more. Otherwise, you'll be reading about it. Okay, let's go ahead and get the sum. Since this thing converges, I guess I gave it away. This does converge because the common ratio is between 1 and -1, -1 and 1. So this thing converges. There we go. And then Landon is going to tell me what it converges to. So can you use this formula up here to tell me what this thing converges to? Ooh, very nice. So I'm guessing that you did this. Take the first term, divide it by 1 minus -3/4. And indeed, you do get 1/7 when you get all the simplification done. Because that ends up being what? 1/4 over 7/4, 1/7. Well done. So geometric series are not terrible. Let's see, what is going on here? There's going to be, okay, how much time do we have? 10:02. Let's take a look at this one, because this one's kind of cool. So what is this? Well, here, we're going to rely on the partial sums to do this one. This one's going to take too long. Oh, but it's so much fun. Okay, yeah, I'll do the hard part. How about I equals 1 to infinity of, this is 1 over I minus, or I, come on. Sorry. Here, let's just get rid of this. Okay, try one more time. This is actually 1 over I minus 1 over I minus 1. So that and this are the same. Using partial fractions, you can figure it out. If you don't believe me, just add these two fractions together and you'll get this. So what I'd like you to do is I'd like you to write down the partial sums. So S1, S2, S3, S4, and S5. And let's see if we see a pattern, which you will see a pattern in a moment. Ooh, this should not start at I equals 1, should it? It should start at I equals 2. There we go. So started at I equals 2. If you start at I equals 1, you end up with infinite. It diverges. But so start at I equals 2. So anyway, if I start at I equals 2, the very first sum, the sum that has a single term in it, is that. The second sum looks like this. 1 over, hold on a sec, 2 minus 1 over, 1 over 3. This should be a 2 here, sorry. 1 over 3, 1 over 2, and then 1 over 4 minus 1 over 3, 1 over 5 minus 1 over 4. Oh, sorry, I got ahead of myself. That's actually the fourth sum. Sorry, I got excited. Yeah, what happens with this one is this interesting thing happens that successive terms kind of cancel each other out. This 1/3 cancels with this. So this is actually sum 4. And then this 1/4 cancels with this. And so what you end up being left with is this, it's called the telescoping series. So I guess maybe we'll have to save this. Actually, it's probably, I'll look for it on the video. So I need to talk about what's going to happen Friday. So let's deal with that, and then we can move on. So I will send you an email tomorrow to remind you of this, just so that you know. But so this, I've got, what I did was I put this under snow days. So I figured no one would be looking there. So under snow days, what you're going to find is down here, I have what to do on Friday, 3/21. So when you click on that, it says, do your homework, and then upload it to the usual spot. And then look at these high quality videos that I made during COVID. So this is 5 years ago. So you can look here and here. So there's some help videos for homework, and then you've got this stuff. So this is what I really am interested in, is this. Oh, I don't specify which ones to watch. Let me see. Oh, I know. Those are the high quality videos for the homework, I think it is. Okay, so then you're going to do the quiz. I'll show you where this is momentarily. Then you're going to watch these videos, the ones for section 11.3. Now, since we didn't quite finish 11.2, you can always watch 11.2 stuff as well. But here's 11.3, is click on that. So this is, so it's 10 years ago, or 5 years ago. This is a long time ago. But let me see, which one is which? I think it's this stuff here. Integrals. The integral, so you can watch these wonderful, oh, look at that. See how happy we are? But anyway, you can watch these videos for the stuff. Let me make sure that I have, hold on a sec before you pack up and leave. Oh, and then you're going to do the homework that's due on Monday, work with a friend. Let me just see, is this stuff here? I think this stuff has, this has, so if you're stuck on the 11.2 stuff, Yeah, here's the 11 point. There's the telescoping series. So telescoping series is right here on there. There I am with the COVID. See, I have COVID inside me, in fact. See, it's, anyway. So anyway, this stuff, the telescoping series is what you're going to want to watch if you're stuck with that. So this stuff will help you with the homework that's due Friday. Some combining series. There's the harmonic series that we didn't get to today. But it's all pretty straightforward stuff. You could also read your book if you want to. I know that's not a popular thing to do, but it is available to you. Finally, there is the quiz, and you can plug in your answers to the quiz here. So you have the quiz here, and then you have your answers to the quiz. And what you're going to do is you're basically going to, let's see, I haven't tried it, preview. Try it. Let me just make sure it works. Oh, yeah. Oh, what? Part A through E? I thought there were only, anyway, yeah, I think you, oh yeah, there it is. So choose the right answer. And if you choose wrong, you can take this multiple times. So you can take it until you get it right. Let me just double check that I have the right quiz here. But anyway, that's what you'll do on Friday. Let me make sure this is correct. ABC. Oh, I uploaded the wrong one. I'm glad I looked. So it should be ABCDE. There's 5 problems. So I'll upload the correct version. It'll look similar, but it'll have 2 extra problems. Basically, you're just determining, do these converge? Do they diverge? If it converges, tell me what it converges to. So that's about it. So you get to take the day off on Friday, but you don't really get to take the day off because you have work to do.